Assalamu alaikum students and welcome to another lecture of Slate. This is Sir Yasin. Let's study chemistry. Now in A-levels, when we talk about physical chemistry, the chapter of chemical bonding and intermolecular forces is very important. If we talk about bondings, you've already studied ionic bonding, covalent bonding and metallic bonding in O-levels. Luckily, there is not much of a difference because more or less, if we talk about that, ionic bonding has the same dot and cross diagram, the same properties. Covalent, it's the same Venn diagram, mutual sharing of electrons, and metallic, again, the same C of electron and delocalized, C of cations and delocalized electrons. But in A-levels, we will further talk about another type of covalent bond, which is dative covalent bond. A very important topic which will give clarity to many of your concepts. And when we talk about the chapter of chemical bonding, it's lengthy, but it's very basic. You need to remember things. And once you do remember things, students, know for sure there are many P1 and P2 questions coming from this chapter. So let's talk about dative covalent bonding. But before that, we need to put light on covalent bonding again. So what do we know about covalent bonding? In the case of ionic bonding, there was a transference of electron and it was held between two oppositely charged ions. But covalent bonding is due to the mutual sharing of electrons between atoms. The term is mutual sharing. You mutually share electrons. By mutual sharing, we mean that if we are sharing an electron pair, like two electrons, one is coming from one side, the other is coming from one side. For instance, chlorine molecule. The reason we make dot and cross diagram, this tells us that both the chlorines mutually shared an electron. So the electron pair, there was a pair and one electron came from each. So that is what we know about covalent bonding. So from here, we will talk about dative covalent bond. This is a covalent bond This is a covalent bond where electron pair is shared by one atom only. So only one atom shares the electron pair. It has free electrons. And when we talk about electron pair, so this electron pair initially was not bonded or did not participate in bonding, right? This did not participate in bonding. So that is what we know from here. Before we do the examples of dative covalent bond, let me take aside a different turn here and understand the concept of lone pair first. So what is lone pair? By pair we may understand it's two electrons. A pair of valence electrons that does not participate in bonding. For instance, if you look at chlorine molecule, we see each Cl has 1, 2, 3 pairs. So, chlorine has 3 lone pairs each. That is what we know about chlorine. If we talk about water, for instance, covalent bonding again. So oxygen has 2 lone pairs. If you talk about ammonia, group 5. So 1 lone pair. So that is what we understand. So if I have to see the concept of lone pair, group 1, group 2, group 3, group 4, group 5, 6, 7, 8. We have these groups. Number of valence electrons. Now that's a very funny thing that we are studying, but we know it is the same. The group number is the valence number of valence electrons. That is something we know already. But number of bonding electrons, number of lone pair. In the case of group 1, for instance, sodium, it has 1 bonding electron which it loses. So 1 bonding electron, 0 lone pair. We've got nothing left. Group 2, magnesium. Remember, it loses 2 electrons to make Mg plus 2. So it has 2 electrons and both of them are involved in bonding. Although it has 2, it has a pair. But both the electrons are involved in bonding. So 0 lone pair. Aluminum, all 3. Silicon, all 4 of them are bonding. So nitrogen or phosphorus, for instance. If you look at nitrogen group 5, nitrogen has 3 bonding electrons and 1 lone pair. That's the division of 5. So 3 bonding, 1 lone pair. Oxygen, 2 lone pair, 2 bonding. Group 7, chlorine, 1 bonding electron, 3. And when we talk about halogen, noble gases, they don't bond. So 0 bonding electrons and 4 lone pairs. So lone pairs are that way. And from now on, if you talk about ammonia, you show a lone pair this way. If you talk about water, oxygen's lone pair shall be seen. Even HCl. So from now onwards, now that you know of lone pairs, you cannot skip lone pairs. Because lone pair do participate in a lot of bonding questions. You're asked to make the lone pairs. You're asked to make the curly arrows. You're asked to show the transfer of electrons. So, this is lone pair. Then we have another concept of radical. A species, it can be any species, it can be an ion, it can be an atom. that contains at least one unpaired electron in the valence shell. For instance, if we talk about Cl2, we just made Cl2, no unpaired electron, not a radical but a molecule. If we talk about just chloride ion, Cl minus, how do we get that? It had one, but it gained one electron. So this is ion, not a radical. Though ions can be radical, any species can be a radical. All you need to do is to see that if it has an unpaired electron or not. For instance, just Cl atom. This is a radical because it has unpaired electron here in the valence shell. So if we talk about atoms like magnesium or aluminum, they can ask you if these are radicals or not. We need to make the electronic configuration there. 1s2, 2s2, 2p6. Now let's jump to the valence one. 3s2. This is paired, not a radical. But when we talk about this one, p1, it is a radical because it has an unpaired electron. So now students, let's get back to the concept of dative covalent bonding, where I said that this is a covalent bonding where the electron pair is shared by one atom only. Let's remember the ion that you all know about, ammonium. Ammonium ion, a very important one. This is NH4 positive. We know that. But how does that form? Ammonia has just 3 bonding electrons. How did it make 4 bonds? And that too with a positive charge. So what happens is, we have an ammonia, let's say, I just made an ammonia somewhere. Yeah. If we talk about this ammonia, and I get, like this is NH3 with 2 dots on the top because it's a lone pair, plus a hydrogen ion. What is the electronic configuration of a hydrogen ion? Hydrogen has 1 proton, 1 electron, but H plus just has 1 proton, no electron, right? So H plus ion has a capacity of receiving 2 electrons. It has an empty shell. So if we have H here, H plus, with an empty shell, what can nitrogen do? Nitrogen has an extra pair of electron, not using and doing anything. Vela pade, kya karenge? We will just transfer it there. And remember, we make a full arrow. Half arrow, 1 electron, full arrow, 2 electron. So this is what happens in case of ammonium. So this the arrow comes there, H plus. And this arrow, my students, is the arrow of dative covalent bond. Dative covalent bond is shown by an arrow. Simple bond with simple lines, dative covalent by an arrow. So what will be the formula of ammonium? I will just make straight lines just to show you the concept. Otherwise, we cannot make these straight lines. We will make dot and wedge diagram that I am explaining in the topic of shapes later in chemical bonding. And now this whole will get one positive charge because all of these are hydrogens. So the charge can shift around, it can rotate, transfer, resonance. So this arrow tells me that this hydrogen was bonded with a dative covalent bond while these one had normal bond. Another example. So this was ammonium ion, carbon monoxide, CO. Like we know, carbon has only 4 electrons, oxygen only needs 6 electrons. And they make a double bond in carbon dioxide. Now, oxygen is definitely balanced, but carbon needs 2 more electrons. If a carbon gives 1 more electron in the bond, oxygen, let's make this mistake here first. Let's say if we put this electron here and this electron here. Now carbon has 7 electrons, but oxygen has jumped to 9 electrons. Illegal. We cannot do that. So let's erase this mistake. So what can happen here? Carbon needs 2 electrons. Oxygen has 2 lone pairs. So oxygen can donate one of its lone pair to carbon and will make a dative covalent bond. So that's what happens here. And ultimately, this happens. So carbon monoxide has a double bond, which is due to this and this, 2 covalent bonds. And 1 dative covalent bond going from oxygen to carbon. That's from where the electron transfers. And 2 lone pairs each. So that is why we make the dot and cross. The double cross tells me that these 2 are from oxygen. Likewise, in case of ammonium, if I transfer it there, you see how there is a dot and cross with every hydrogen, except the one where it made dative covalent bonding. So that is the concept, students. Now, last and a very important example of dative covalent bonding that mostly comes in the exam. So, aluminum chloride at high temperature, around 180 degrees Celsius to 200 degrees Celsius, it dimerizes to this. Dimerizes, which means 2 will polymerize, like polymerization. So 2 will add up. So what do we have in aluminum chloride? Let's see. Al group 3. 1, 2, 3. 3 Cls. What do we see? Aluminum has 6 electrons. Chlorines are full, having 8 electrons each. But aluminum still has a capacity of 2 more electrons. So what happens at this high temperature? If I have one aluminum chloride, I'll show the lone pairs of chlorine. Then I have another aluminum chloride. So obviously 3 Cls. So what happens at this high temperature? Both the aluminums have a capacity to receive 1 electron pair. Both have too many chlorides, Cls, chlorine atoms. This chlorine is going to donate its pair here, and this chlorine is going to donate its pair here. And when you do the donation part, you remove the electrons because they are not lone pairs anymore. They participate in bonding. And that, my students, is the structure of Al2Cl6. You can also write it this way. This is the messier way, dot and cross diagram, if I have to make a dot and cross diagram. Now that's one chlorine, but we have 2 AlCl3s. So if I have another AlCl3, this will bond with this aluminum with just its same electrons. Like with this one, with this one. Now this is the dot and cross diagram of AlCl3. You can make the circular one, you can make it this way. But what do we know? That most of the electrons these are covalently bonded, dot cross. But these two are datively bonded. So Al2Cl6 has 2 dative bonds and 6 covalent. Likewise, carbon monoxide, 1 dative and 2 covalents. So students, this is the concept of dative covalent bonding. Remember, an electron pair is shared and we get arrow for the bond, not a straight line. So thank you so much for being here with me. Take care and Allah Hafiz.